All right, welcome back. Hononegah, Algebra 1. 8.3, today we're going to be dealing with graphing more quadratic functions, but in a different form. So far we've done what's called vertex form. And vertex form is nice because it ultimately gives us the vertex. So this form doesn't necessarily give us the vertex right away, so we got to work a little bit harder to find the vertex. Quadratic function is a function with degree of 2. So x squared, the highest power would be a 2. Now a parabola is the graph of a quadratic function. Vertex is the highest or lowest point. So the highest point if the parabola is going down, and it's the lowest point if the parabola is going up. So at the bottom or the top, the absolute bottom or the absolute top, axis of symmetry, symmetry means the same on both sides. So the axis of symmetry is a line, cuts the parabola symmetrically. And then the last one, not my favorite question, but it does make more sense in this particular. The y-intercept is the point the graph crosses the y-axis. And so there'll be a formula for y-intercept in this particular situation. So again, this particular lesson, the y-intercept will make a little bit more sense. Find the coordinate of the vertex. Anytime you want to find the x coordinate of the vertex in a standard form equation, and I really should write that out first, ax squared plus bx plus c. So notice nothing is squared, or excuse me, nothing, there's no parenthesis being squared. We've got an a, a b, and a c, and the b could be 0, so that's okay too. But a is the lead coefficient, or the number in front of the squared term. B is the linear term, or the coefficient of the x. First, you're going to find what's called the axis of symmetry first. So this equation is technically the formula to find the axis of symmetry. Then we'll make a table of values with the axis of symmetry being the middle. And so there's a little, okay, the vertex is always in the middle of the table. So whatever the axis of symmetry is where the middle of the table should be. And then we'll plot our points. So here we go. A is the number in front of the x squared term, so A is 1. B is the linear term, or the number in front of the x, so that's 2. And C is the negative 5. So there's my formula for the axis of symmetry. X is equal to negative b over 2a. So negative b over 2 times a. The axis of symmetry line is negative 1. So down here, x is equal to negative 1. That is the equation of the axis of symmetry. The vertex has to have negative 1 in it. So when I do my XY chart, negative 1 is the middle of my graph, because that's the axis of symmetry. Axis of symmetry goes through the vertex, cutting the parabola symmetrically. So now I want numbers that are bigger and smaller than negative 1. Plug 1 in, and you have to plug 1 in for both x values. So it's 1 squared, 2 times 1 minus 5. So you have to plug the number that you're putting in for both x values. So I end up getting negative 2, 0, negative 5. And that point right there is always c. Y-intercept is always whatever the c value is. So there's another answer to the question. It's going to touch the y-axis in the point 0, negative 5. So whatever is the c term, that is always the y-intercept. We'll keep going here. I'm going to plug negative 1 in. Now, negative 1 squared, so always square something. 2 times negative 1 minus 5. And so I end up getting negative 6. And then when I plug negative 2 in, I get negative 5. And when I plug negative 3 in, I get negative 2. So I'm going to graph all those. So negative 1, negative 6, 0, negative 5. Again, that is your y-intercept. negative 1, or positive 1, sorry, negative 2. So the domain, or so the vertex was at negative 1, negative 6. I got to make sure to go ahead and write that into the blank. There are a lot of people that actually forget, they have it in their XY chart, but they forget to write it in the blank. Domain, I'm going to scroll down here because there are two questions here. Domain and range. So the domain is always all real numbers, just like it was before. And again, just like it was before, we're talking about y being either greater than or equal to or less than or equal to. In this case, it's going upward, so greater than or equal to the y value of the vertex. So the vertex helps me get the axis of symmetry, and the vertex helps me get the range. Same thing. A is negative 1, B is positive 4, C is negative 4. So if you want to go down here and go ahead and do the y-intercept question, you can, because it's always 0C. X equals negative B over 2A. So negative 4 over 2 times negative 1. So I end up getting positive 2. So I'm going to put positive 2 in. Find the vertex. So I'm going to put, or excuse me, I'm going to put 4 in for both x's. Now, the negative sign is outside. You square the number, then times it by the negative. That is a very common mistake here. So I end up getting negative 4. 3. So I'm going to get negative 3 squared plus 4 times 3 minus 4. Negative 1. And then 2 is negative 4. I apologize, I plugged that in wrong. 2, you get 0. And then 1, you get negative 1, 0, negative 4. So I'm going to graph those points on the graph. So 2, 0 is the vertex. 3, negative 1. 4, negative 4. So there it is. So I've found the vertex to be at 2, 0. Axis symmetry, already found that to be x equals 2. And so now for domain and range. This is a downward parabola. So the domain is going to be all real numbers. Range is going to be y is less than or equal to, and whatever the y value of the vertex is. So y is less than or equal to 2. 2, negative 4, negative 1. I'm kind of all over the place, but the C is negative 1. So there is your y-intercept if you want to do that. Negative, negative B. So it's negative B, and B is already negative. So we're talking about a positive. So 4 divided by 2 is, or 4 divided by 4, sorry, is 1. So my axis of symmetry line that I just found is x equals 1. And now I need to put 1 into the equation because that's going to be where my vertex is located. Numbers that are bigger and smaller than 1. And I'm going to plug each one of those in. So 2 times 3 squared minus 4 times 3 minus 1. So notice I'm putting the number in for both x's. So that would be 18 minus 12 minus 1. So 6 minus 1 would be 5. 2 squared minus 4 times 2 minus 1. So we got 8 minus 8 minus 1. Plug 1 in. 2 minus 4. Negative 2 would be negative 3. And then again, 0, negative 1, and negative 1, 5. So I'm going to graph all those. 3, 5. 2, negative 1. 1, negative 3. So my vertex is at 1, negative 3. And now for my domain and range question. My domain is all real numbers. And the range, this parabola goes up, so it's greater than or equal to. And then it goes up from negative 3. A is negative 2. B is positive 4. C is 1. Now, there is a pattern to this, and I don't, whether or not it goes up or down, things like that, there are patterns to this. When I teach this in my Honors Algebra 2 class, I do actually go through that pattern, but I don't recommend it for this class. And I'm actually going to do this one on a graphing calculator as well. So negative B, 2A, so negative 4, negative 4. I get 1. So my axis of symmetry is x equals 1. The C value was 1, so I'm going to go 0, 1 for my C value. I'm going to put 1 in for x, and then I'm going to do numbers that are bigger and smaller. So let's say I put 1 in. I end up getting 3. I end up putting 2 in. I get 1. And I end up putting 3 in. I get -5. So I'm going to plot all those. So 1, 3, 0, 1. So we already established the y-intercept. And 3. And notice it's the same on one side that it is on the other because it's symmetrical. Domain is all real numbers. And the range, and I know I didn't write this in. Again, got to make sure to write that in. Y is less than or equal to, because it's going down, 3. So did anyone notice a pattern? The first point on either side is always the A value away. So you'll notice that this point is always down 2 because the A value is 2. So each time it's always 1A. And then the second one is always 4A. So you go over 2 and down 8. So there is a pattern here. When does the parabola, I'm going to scroll, when does the parabola open up and when does it go down? If the A value is positive, it's going to go up, and if the A value is negative, it's going to go down. Going all the way back to the first slide now, your homework assignments is out of the, or sorry, is a worksheet. So make sure you double check your Google Classroom with your teacher. If you have any questions, please make sure you ask, and good luck.